Hello everyone, hope you're having a great day today. So today we are talking about motor behavior. This is chapter 5 and the first of a 4-part series. So motor behavior is a broad umbrella term used to encompass the areas of motor control, motor learning, and motor development. So here we go. One of the primary concerns of physical education, exercise science, and sport professionals is the learning and refinement of motor skills. Learning is defined as a relatively permanent change in behavior or performance as a result of practice or experience. Motor behavior is concerned with the learning or acquisition of skills across the lifespan and encompasses 3 areas of motor learning, motor control, and motor development. We'll talk about each of these as we go. Thomas and Thomas identified 3 goals of motor behavior. First, to understand how motor skills are learned. Second, to understand how motor skills are controlled. And third, to understand how learning and control of motor skill changes across the lifespan. All of these areas, although highly specialized, are interrelated. Although researchers in these areas focus on slightly different questions, a more highly integrated approach to research is seen today. Motor learning and motor control are very much interrelated. Motor learning is the study of the acquisition of motor skills as a result of practice and experience. Learning is inferred from changes in performance. For example, an instructor determines whether an individual has learned a tennis serve by observing and assessing the individual's performance. As the individual receives instruction and practices, performance of the tennis serve should improve. That is, it becomes more consistent, effective, and efficient. You're hitting it into that square. You would then infer from the individual's performance that learning has occurred. Motor skills range in scope from simple skills such as learning to walk to highly complex skills, such as those shown by an elite gymnast performing intricate tumbling passes as part of a floor exercise routine. Motor learning focuses on studying the cognitive aspects of motor skill acquisition. According to Thomas and Thomas, the goals of motor learning are understanding the influence of feedback, practice, and individual differences, especially in how they relate to the retention and transfer of motor skill. Motor control, on the other hand, is the study of the neurophysiological and behavioral processes affecting the control of skilled movements. Intimately related to the area of motor learning is motor control. Motor control is the study of the neurophysiological behavior processes affecting the control of skilled movements. Thomas and Thomas summarize the goals of motor control as a sequence of movements Thomas and Thomas summarize the goals of motor control as understanding how the muscles and joints are coordinated during movement, how a sequence of movements is controlled, and how to use environmental information to plan and adjust movements. Researchers in motor control are interested in the processes underlying the learning and performance of motor skills, such as how the nervous system works with the muscular system to produce and coordinate movement, and how cognitive processes are involved in the learning and execution of motor skills. Motor development looks at the study of the origins of and changes in movement behavior throughout the lifespan. There are many theories that have been advanced to explain the process by which motor skills are learned and controlled. These theories help researchers formulate models to illustrate how learning occurs. Models developed from these theories serve as frameworks for professionals. They help professionals design and implement learning experiences for participants in their programs. The information processing model and the dynamical systems model are 2 models that have been used to describe motor skill acquisition and performance. Motor learning, again, is the study of the acquisition of motor skills as a result of practice and experience. We'll be talking about the information processing model and the dynamical systems model in our next session. So motor behavior is concerned with the learning or acquisition of skills across the lifespan. So it includes both the motor learning, motor control, and motor development. And if you have children or you have brothers and sisters, these are the milestones of motor development. So at 5 to 8 months, they should be sitting on their own without any help. They're developing that core, and they do that by their tummy time, as an infant, being able to lay on the floor and be able to learn how to control their core. You learn from your core out. We'll talk more about that as we go. You learn from your core out to your extremities, and gain those fine motor control systems a little bit later on. 8 to 11 months, you're starting to crawl, and then 12 to 15 months, they're starting to walk. Now, it depends upon the individual. Everybody is different. It depends upon the environment that they are in, the stimulus that they've been given, and all of those things. If they have brothers and sisters, then they're usually up and walking and running very soon to catch up with their brothers and sisters. Within 2 years, they're able to kick a ball, they're able to run and go up and down steps. And 2 to 3 years, they're able to stand on one foot and jump. And then 3 to 5 years, they're starting to develop those manipulative skills of catching and throwing the ball, climbing, skipping, and hopping. And then 5 to 7, they're catching and throwing small ball, standing on one foot for a period of time for 10 seconds or so. So some definite milestones, and it's fun to watch those. I have to tell you, I'm going to be a Mimi soon. I'm excited to see all of these milestones with grandkids. The early period from 1880 to 1940, the middle period from 1940 to 1970, and then the present period, 1907 to present day. During the early period, although researchers investigated the acquisition of motor skills, their research focused on trying to understand how the mind worked, rather than seeking to understand how skilled movements were produced. One significant development was Thorndike's research on learning in 1927, which became known as the law of effect. Thorndike found that when responses to a situation were rewarded, they were strengthened and used more frequently, and hence became learned behaviors. Thorndike's work influenced subsequent work and the impact of feedback on motor skill acquisition. Adams reports that it was during this early period that the basis for research in 5 major areas of motor learning was laid: knowledge of results, distribution of practice, transfer of learning, retention, and individual differences. Motor control researchers were interested in the qualities of muscle. The discovery that the brain produces electrical activity stimulated interest in the relationship between brain electrical activity and movement, which helped further researchers understand of how the nervous system controls muscles and movement. The start of the middle period was marked by a surge of interest in motor learning. World War II had stimulated an interest in pilot selection, and training. Motor learning research focused more on application, investigating such areas as transfer of training, what factors would enable a pilot to easily and successfully switch from flying one type of aircraft to another aircraft that was of a different size, with controls positioned differently. In the late 1940s, Craik advanced his ideas about the similarities between the human brain and the computer, which gave new insight into how the brain processes and uses information to influence the motor response. And in the 1960s, Franklin Henry published his landmark paper on the memory drum theory, which discussed the role of cognitive activity in motor learning. Often considered the father of motor behavior, Henry, with his contemporaries Fitz Hubbard, Jack Adams, Arthur Slater Hamill, and John Lother, helped set the stage for the emergence of the subdiscipline in the 1970s. The 1970s marked the emergence of motor learning and motor control within physical education programs. During this time, motor behavior scholars began to move from the application of theories from psychology to the development and use of their own theories and models to explain motor skill acquisition. In 1971, Adams' closed-loop theory explained how feedback following the performance of slow and discrete movements is used to update the cognitive representation of the movement and improve subsequent performances of the motor skill. In 1975, Schmidt's schema theory proposed the idea of a generalized motor program. That is the idea that movement patterns such as kicking or throwing could be generalized to a variety of sports and settings. These are just a few of the sample questions that researchers in motor learning and motor control may address, such as how do the type and frequency of feedback impact skill acquisition? How does the structure of practice influence the retention of skills? And how does skill performance change as beginners move from novice to advanced levels of performance? And here are just a few others. How does the aging process affect motor control? And how do specific diseases such as Parkinson's disease affect an individual's ability to perform motor skills? When teaching a skill such as serving in tennis or pitching, should you emphasize speed first or accuracy? I'll be asking y'all that question. It's a good one. How do differences in individuals' learning styles influence their ability to learn motor skills? So that's where we're going to stop today. I want to talk more in our next session about those theories of motor control and motor learning. So kind of expect to see that. I'll talk with you soon. Y'all have a great day today.